completion of PhD by this year. He is one of the best teachers we have. We are extremely thankful to him for making this chapter possible and also for being here today with us. Now I humbly ask Mr. A. Vinod sir to please share a few words with us.
Thank you, Pulkit. So, good evening, everyone. So, it is my pleasure being a part of this SRM student chapter of Material Advantage. So, about this student chapter, we are just a newborn who is trying to expand ourselves into different fields of material applications, and had come up with organizing few of the technical sessions and as well as webinars. So, regarding today's session, we are glad and very much thankful to our speaker, Mr. Nishant Govindarajan, who is an engineer from SRM Niki Auto Systems, who has accepted our invitation to be a resource person for this technical talk, despite of his busy work schedule and that too on odd timings after office hours. We are welcoming you, sir. Also, we are welcoming all the participants of this technical session. So without their support, these sort of online sessions at this current situations are not possible at all. So, and also I'm thanking our speaker for proposing an interesting topic of discussion as outlook of Indian automobile market. So since our younger generations are much crazy on automotives, so hoping that everyone will have a fruitful session and will have an insight into the current scenario of automotive industry. So with this, I'll thanking all the organizers who has come up with this sort of technical event which has been organized in a well manner. So all the very best for all of you. Stay blessed and safe at this pandemic situation. Thank you all.
Thank you, sir, for your words.
Some,
Please kindly type your doubts and questions in the chat box. All questions will be entertained after the lecture one by one. And also, don't forget to fill up the feedback form. E-certificates will be provided on the basis of attendance and feedback form. The link will be provided during or after the lecture in the chat box. Without wasting time, I would like to ask Mr. Nishant sir to please take the metaphorical mic.
Good evening to everybody. I would just like to check whether I'm audible.
Yes, sir, you are audible.
Great. Okay. So, good evening once again. Thank you, Mr. Vinod sir, for that warm welcome, and Mr. Polkit for that great introduction. Very sweet of you. Thank you.
thank you, sir.
So, hope everybody is safe and sound in this pandemic situation. I know the vaccines are getting rolled out, but unfortunately not for us. So, we still have to be, masked and have to wash our hands for the benefit of our, elders and the older people in our families. So thank you everybody for this huge turnout. 45 people is not a joke. So thank you very much. And I especially would like to thank most of the students who have come. And I think few of my LinkedIn connections are also here, and especially my mentor and guide, Professor Sedupati from the Automobile Department. So thank you very much for attending. I hope you have an interesting session. And thank you for the invite as well. So let's start with the presentation. I'll start presenting my screen. I'll turn off my video to prevent any discrepancies.
Yes, sir. Yes.
Hope my screen is visible.
Yes, sir. Yes, sir. Your screen is visible.
Okay, great. So, good evening, one and all. So, the topic of the day is an outlook of the Indian automobile market. So, most of you might have a car, most of you might have a two-wheeler, you might aspire to own a car or a two-wheeler later on in life. So, it's best if you know which one to buy, which company is the pioneer in the new technologies and safety space. So I first would like to take you on a walk through the avenue of the two-wheelers, four-wheelers, commercial vehicles in the current Indian automotive market, and then also to few emerging technologies in the automotive space, which are set to hit our Indian automotive market in the next 2 to 3 years. Then finally, we will go on to one of those emerging technologies, electric and hybrid vehicles. Then we can also see a small research paper which my mentor, Professor Sedubadi, me, and a couple of my colleagues have done. So without further ado, let's move on to the first, let's see the agenda first. So as I said, we'll see the key players in two-wheeler, four-wheeler, commercial vehicle space in India, automotive industry disruptors, the emerging trends, hybrid electric vehicles, and we're going further into hybrids based on architecture, hybrids based on the level of hybridization, the overview of the components in an EV or an XEV, battery types, motor types, charging equipment, my research paper, and finally, we will go on to the interaction session. I would like to keep my lecture short so that we have more time for interaction. So let's start. Now, let's start with the key players in the two-wheeler space. How do you judge, the success of a company? It's all based on the sales data. How much is being sold every month? How much is being sold every quarter and every, uh, every year? So first, let's start with last month's data. So we are in April, so the sales data won't be out for another week or so. So let's start with not March, but February. So this is the sales data, which contains the sales made by the OEM, that is from the factory to the dealership. So as you can see, Hero MotoCorp have the most sales at 4,84,000 units. That is 4 lakh two-wheelers have been sold by one company to the dealerships throughout India in 1 month. So following that is Honda, which is again 4 lakh, and followed by TVS, homegrown TVS and Bajaj Auto and Royal Enfield at the back of the pack with 2 lakhs, 1.5 lakhs, and Royal Enfield 65,000. So all this amounts to around 14 lakh two-wheelers which have been sold in 1 month. I just want you to wrap your head around this. 14 lakh two-wheelers which have been sold in 1 month all over India. But do we see so many, 14 lakh two-wheelers on the road? Not so. So this data is called wholesale data, which is the data sold by the data for the two-wheeler sold from the OEM to the dealership. So the key data which we have to see is the data which is, how many two-wheelers have actually been bought by the end consumer, which is you and me. So that is given here. So as you can compare the first data, 4,84,000, say Splendor sold, but actually how many people who have actually bought a two-wheeler are only 3,50,000. So once you wrap your head around that, you get only 10 lakh, 11 lakh sales. So 14 lakh might have been sent out of the factory with only 11 lakh are on the road. But market share doesn't, waver that much, because as you can see in the wholesale data or the retail data, which is on the side, right side, Hero have a commanding market share of 34%, and which is reduced, very negligibly to 32%. So Hero MotoCorp initially were Hero Honda, were one of the pioneers in the Indian automotive two-wheeler segment, and now I think they've last week they rolled out their 100 millionth bike, and they had a huge celebration for that. So this is a common sight on the roads, which is the Hero Splendor, which has been on sale for the past 20 plus years, which is using the same chassis, the same wheels. The only thing different now, owing to BS6 regulations, would be a fuel-injected engine. But there are sources where you've heard of, a small company, a tier one company, a large fuel injection system supplier. I don't want to reveal the name. Has tried out an electronic carburetor system for few of their bikes. So it still holds on. This is one of the very few bikes in the BS6 era to be sold with a carburetor rather than a fuel injection system. Then the second, this is the most sold bike in the country. The second most sold bike or two-wheeler is the Honda Activa. The Honda Activa also has been, has been driven by every other father, mother, grandparent in the family, and finally it ends up to you. You might have brought it to college. So the Honda Activa is the most sold scooter in the country, and it's the second most sold two-wheeler overall. I think we can move on to the four-wheeler space. So obviously, Maruti Suzuki is the key player in the four-wheeler space with 1.5 lakh cars being sold every month. This is just by one manufacturer, which has a potential, a substantial growth of 8.3%. That is over the last month, and a market share of 47%. So every other car you see on the road is a Maruti Suzuki. Despite all the hindrances to the safety norms, people say Maruti is a tin can, it doesn't have safety. All that is there. Despite of that, people buy 1.5 lakh cars a month. So that ends up to 3.1 lakhs per month, 3.1 lakh cars per month. Retail data is not very far off from the wholesale value, which is around 2.5 lakh cars a month. So obviously, the uh, Maruti Suzuki is the first best in terms of sales, mind you, player in the market. And you might have seen over the past few years, the best-selling car would have been the small Alto, the Alto 800, which is the cheapest car in their stable. Of late, 2019, 20, and 21, we are currently in 2021, but the trend shows that the best sold car is the Maruti Swift, which is, say, a mid-size hatchback, which is lower than the Baleno. So you would think, why are people going for this? People in the olden days would want only just Maruti, just for the fact that they have the sheer number of service centers and spare parts availability. Now people don't mind. They spend a lot more on their car loans. They get a base model car and then put whatever accessory they want to it. The accessories for the most sold cars, Swift, Creta, Baleno, have popped up in every single street vendor. It's that easy to get. So the second most sold car is the Baleno, and then after this you get the Alto 800. So consumer is king or queen. Their expectations are changing. Initially, you would just want a car to replace your bike, but now you want a car with air conditioning, with smartphone connectivity, connected car tech. You would want to know where your car is parked 5 kilometers away. You want all these things in the car. Ultimately, we'll end up with consumers wanting cars which can autonomously come pick them up and drop them off at their location. The second one is Hyundai, and Creta is the most sold car. Imagine an SUV is the most sold car of a brand. We'll move on to the commercial vehicles. So unfortunately, commercial vehicle wholesale data is a closely guarded secret. It is not, viable, and it's not available to people like you and me. It is only available to the dispatch teams, the marketing teams at the respective companies. But this is the retail data. This actually shows how many trucks are there on the road and how many buses are there on the road. So this is no surprise. Tata Motors are the pioneers and the market leaders in the commercial vehicle space. That is for trucks. Second, the most sold bus in the country will be an Ashok Leyland, which is why the Tata 407 pickup truck chassis platform has not been changed for the past 36 years. The same platform has been used over and over and over again. The only thing different now is a BS6 engine with after treatment systems like SCS, selective catalytic reduction system, and lean NOx trap. But apart from that, the chassis is same, cabin is same. You might get few connectivity features. That's all. An interesting point to note is that very same chassis used for the Tata 407 was used in the Tata Sierra, in the very same engine too, initially, before the petrol engine came into the picture. Ashok Leyland is a very well-known name. They produce the most buses in the country, and they are fourth in the world overall. So this is the latest rendition of the Ashok Leyland Viking bus, a bus which has been in India for over 40 years. You might recognize all your NTC buses and your, the orange and beige buses. All of them at one point were Vikings. The body might be somebody else. You have Prakash, Veera, and all that, but and Eraser TVS, but the chassis is in Ashok Leyland Viking. Now let's move on to the electric vehicles. So these are the two-wheeler OEMs which are producing electric vehicles in India. Again, like Hero MotoCorp, Hero Electric is the market leader, which who shells out 2,000 electric vehicles a month. And then you also have Okinawa, Ampere, Ather Energy, and every other, and TVS and with Bajaj. Every other OEM in this just rebadges Chinese um, two-wheelers. They import it from China, they rebadge them, sell them in the Indian market. You might have a very, very small degree of localization, but this is what happens. Moving on to the four-wheelers. Unfortunately, we do not have much choice for four-wheelers. We have Tata Nexon EV, we have an MG ZS, a Hyundai Kona, and a Tata Tigor. And they have not much growth in the four-wheeler segment because unfortunately, even though there is a scheme by the government which is faster adoption for electric and hybrid vehicles, unfortunately, the tax concessions are not for the four-wheelers. You have concessions for the two-wheelers based on your battery size and the speed at which it goes, but none for the four-wheelers. So obviously, this is a Tata Nexon EV, and which is well known in the EV space, and the Hero Electric Nix, which looks exactly like the Pleasure, but this is an EV only model. Now, let's move on to the key disruptors in the automotive industry. You might have seen this case keyword, in most of your conventions or conferences you go to. What exactly is CASE? CASE is an acronym which stands for Connected, Autonomous, Shared, and Electric. So what do you mean by a connected car? The car would have an embedded eSIM. It can talk to the other cars. It can talk to cars in front of you, behind you, see where the location you're going to, all through the internet. So you might have heard of the MG Hector, Internet Inside connected car, whatever. That is not the actual connected car. That is just a gimmick, which connects your phone to the car, saying, "Hello, MG, open this, open that, open the sunroof, open the window." Kia also has that in the Seltos, but that is just a gimmick. The real actual connected car would be a vehicle which can talk to the other vehicles in your lane, see where they are going, and effectively manage traffic in a way which increases your fuel efficiency, reduces your accidents, and takes you safely and back to your home. You can also, end up in one situation wherein you hail for a car or a taxi or a van through an app, obviously, and it takes you to your desired location. If you want to go to another stop on the way, say a coffee shop, it will geo-fence you and check where the location of that coffee shop is. And if it's an electric vehicle, it will also check whether you have the battery power required to take you there and then back to your house. If it doesn't have the battery power, it will search for a charging station close by the coffee shop, charge the car while you have a bite, and then take you back home. So the last picture here would be very, very familiar to all of you, which is a Tesla, who are the pioneers in the electric vehicle movement. I think they have 4 cars now, and they have a revolutionary battery technology with those little cells, like an AA battery, and an induction motor, which is beyond excellence, beyond par to anything which is on the road. Let's move on. Now, the emerging trends. You might have heard of Industry 4.0. Initially, you have mechanization, and where you have steam power rather than people, doing manual labor, which moved on to mass production and assembly lines using electricity. Finally, we are in the current stage wherein you have automated production systems, IT systems, and robotics which control. We will move on to Industry 4.0, wherein your system would be able to detect flaws and detect bottlenecks and stop the system, which enables you to rectify the errors. Suppose you have a huge production line with four machines. Suppose there is an issue with the third machine, the first two machines will cease to prevent the buildup of components from centers 1 and 2 until you fix the third machine, or suppose you might evolve into a self-fixing system where it rectifies the issue of the third system, and then it will continue with processes 1, 2, 3, and 4. All this is not standalone possible. So you will need the machines to be connected via AI, Internet of Things, and machine learning. Let's move on to the hybrids and electric vehicles, which is the talk of the day. So this is what you call as a hybrid, and this is what you call as an electric vehicle. I've picked these two cars as they are very familiar. The Toyota Prius has been the pioneer of the hybrid vehicle movement. Toyota believes in hybrids. They still have, Prius's testing, and you have a Prius, I think, in its fourth or fifth generation now, which is what you see here. They also believe highly on fuel cells, which I believe are the future. And obviously, this is our homegrown Tata Nexon EV, which, with its revolutionary Ziptron EV tech, has made EVs slightly affordable. Why I say slightly? Because it still costs, close to 20 lakhs, even with the road tax. And it doesn't take you as far as the traditional combustion engine car takes you, but we are getting there. So a few key aspects of the hybrids. You have two propulsion sources. You have one internal combustion engine and an electric motor. How and when, what powers the car, we'll come to it later. As of now, there are no tax concessions by the Indian government for hybrid vehicles. A few OEMs were lobbying the government to give them concessions on hybrids, but it's still, they are at loggerheads. So obviously, a hybrid gives you more range than an internal combustion engine, because as and when the engine shuts off, the engine either powers the car, powers the battery, which charges the motor, or it shuts off completely and only goes on green EV power. The only issue is that since you have a heavy electric motor on board in addition to the internal combustion engine, it is slightly more expensive than the internal combustion engine. Let's move on to the simple, as it sounds, EV. You have a car, you have a battery pack, you have a motor. Enough said. The battery powers the motor powers the car. How you charge the battery is very, very important, because if you simply use, a diesel generator or electricity got from coal or non-renewable resources, then you're back to square one. It's no better than driving around a diesel car polluting the environment. Obviously, you get lesser range than an internal combustion engine. If you take a regular Nexon, the ARAI rated mileage, I think, is around 18 or 19. I'm not very sure. It's around 18 or 19. But the EV has a range of only real world range of 150 kilometers, which is in no way comparable to the internal combustion engine. Now, since the batteries, we are still in the era where batteries are not cheap, and we haven't found easy ways to recycle them and increase the longevity of their life. They are very, very expensive. This car costs 20 lakhs, the battery alone costs 10 lakhs. And that's not all. You might think it's fine, 20 lakhs, 10 lakhs, but I can keep running the car for 10, 15 years. That's not the case. You have to change the battery every 6 to 7 years. So every 6 to 7 years, you make another additional investment of 10 lakhs, which in our scenario is impossible. We don't have the luxury of having one car to commute to work, one car for the weekend, one car for the family trips, one car to go buy some groceries. We Indians use one car. I use my 17-year-old Zen to commute to work, to buy groceries, to take my family out for a trip, and to drive in the weekends. But there are certain tax rebates for the electric vehicles. very few state governments have decided to forego road tax for the EVs. For example, the Tamil Nadu road government has given 100% tax rebate, which means you do not have to pay road tax for your Nexon EV. Now, what is the solution? Why are we going on to hybrids and electric vehicles? Because we are polluting the environment. So the hybrids are the immediate solution because we've been used to internal combustion engines, petrol, diesel, CNG for a long time. We can't just say, fine, to hell with it. Tomorrow I am going to sell my petrol and diesel car and buy an EV. That is not the solution. So the immediate solution, you need a bridge to move on from one place to the other, from one mountain to the other. So that bridge, immediate bridge, is the hybrid vehicle. Long term would be the electric vehicle, but not with batteries. The batteries will have to be replaced with fuel cells. That fuel cell can be either a hydrogen fuel cell or any other, advanced technology which comes up. Now let's move on to hybrid vehicles based on architecture. What do you mean by architecture? What are the components there in my vehicle? What is powering my vehicle when? So I will show you the first architecture, which is a series hybrid. This is simple, really. You have an internal combustion engine, which is fed fuel by a fuel tank, diesel or petrol. This runs a generator. The generator goes on to the power converter to convert either DC AC or AC DC or step up, step down. Goes on to the battery. Now the battery provides electricity for the electric motor, and if it's a car, it goes on to a gearbox, and not a 5 6 speed, either a 1 speed or a 2 speed gearbox. And then finally this drives the wheel. So this is simple. IC engine, generator, battery, motor, the car goes. This is simple. Second thing, the parallel hybrid. You can either have an IC engine powered by petrol or diesel, coupled to the car, transmission of the car, which propels the car, or you can have an electric motor powered by batteries propelling the car forward. But in this case, suppose you run out of battery power, your car can still move along because you have an IC engine. The next case, the series parallel hybrid. Suppose you say, fine, I've run out of batteries, but I want to still propel my car using the electricity. So it's fine. You use your IC engine propelling your car out on the highway, wherein you have higher speeds where the electric motor can't keep up, and in low speeds you use the electric motor, that is in traffic conditions, start-stop conditions, and also heavy bumper-to-bumper traffic. Speeds of say up to 20 or 30 kmph, use the electric motor, and you don't have to worry saying, do I use this engine, do I use the electric motor? Everything is taken care of by an onboard computer. So it's simple. There is no driving change for the driving style change or driving behavior change for the driver. Let's move on to the most complex architecture, which inevitably is named a complex hybrid. So what does this do? You can either have an engine powering the car by itself, or you can have the engine powering the battery, which is powering the motor, which powers the car, or you can have the battery powering the motor, which powers the car, or this is very complex. You have the engine powering the wheels, at the same time it charges the battery, and the battery charges the motor. Battery gives electricity to the motor, and the motor also propels the car, which is like extra boost. I hope this is clear, and we can move on to the next one. Now, hybrids based on the level of hybridization. So there are very, very clear-cut four hybrids. You have your micro hybrids, which have the integrated starter generator, but use only start-stop. So that's the only thing they have, plus some regenerative braking. Then you have the same ISG with start-stop, but they actually use that energy recovered from regenerative braking to propel the car. Third, you have the mild hybrid, like the Prius. Not the full Prius. You have like the Okay, I'll tell you when the examples come up. You have a mild hybrid, which you have a smaller engine than actually is big enough to power the car, but is compensated by the electric vehicle's motor. And at last, you have the full hybrid, which is a Prius, which you can use either the engine propel the car or the motor, or the engine powers the car while the motor uses it, or however is possible. So let's see the finer details. The engine would be a conventional engine for the micro hybrids. The mild hybrid and full hybrid will have a downsized engine. You might have heard of, say, 1 liter, 1000 cc engines, three-cylinder engines with turbocharged power. Those cars, if they did not have a turbocharger, will use a 2 liter, 2000 cc naturally aspirated engine, which produces slightly lesser power and torque than your 1 liter turbocharged engine. The electric motor for the micro hybrids would be integrated into the belt. Like now you have the starter motor on the flywheel. This would be a belt driven one. The ISG hybrid, the second column, would be either a belt or directly on the crankshaft. Similarly for the mild hybrid. The full hybrid will definitely be on the crankshaft. Now, how much power would, would be added to each hybrid? You might have 2 to 5 kilowatts of power, 3 to 10 kilowatts for the ISG hybrid. And for the full hybrid, you would have a substantial increase in power, so say 15 to 100 kilowatts. So what exactly is kilowatts? We are not used to kilowatts because that is an electric motor term. We are used to horsepower. So how much kilowatt is 1 horsepower? So when they talk about 100 kilowatts, we are talking about 134 horsepower. So imagine an engine which has 150 horsepower just from the engine. The amount of boost you will get from the electric motor for the full hybrid would be an extra 134 horsepower. So in essence, you have a vehicle which has 274 horsepower. I feel this is something to brag about rather than having a 5 liter V8 with 250 horsepower. Okay, that's an exaggeration. You get the picture. Operating voltage also would be a standard 12 volt like every other car for the micro hybrids, and it moves on. Fuel economy improvement. Now, this is why we are coming to hybrids. The most fuel economy improvement you would get from the hybrid would be 30%, and it will go as low as 3%. Now, it might not look that impressive in numbers, but in the real world, it counts. Now, let's see the examples. Who started the micro hybrid, car in India? You might not believe it, but it was a huge gas guzzling SUV called the Scorpio ZLX micro hybrid, which had start-stop technology, which started off this micro hybrid revolution in India. So it only had plain start-stop. Now you get automatic start-stop. When you press a button, it automatically senses you've come to a junction, and the gear is in neutral, the clutch is not depressed, the engine shuts off. And it automatically starts again when you press your clutch. But there is some issue because although you get a few tax rebates because you get start-stop, the electric motor doesn't actually power the car, doesn't give you a boost, which is why we come to the next one. You might have seen the Ciaz or the Swift or the Baleno with the Suzuki's SHVS technology. Initially, their diesels had it. You have start-stop, you have regenerative braking. You also have the motor, which helps you give additional acceleration in low-speed conditions. Now we come to the mild hybrid. What is this, you might ask? It's a very old Mercedes ML class, which is now the GLE. That had a mild hybrid system. Initially, you would find a 2000 cc or 2500 cc 6-cylinder diesel engine in this car, but this had a 4-cylinder diesel with I think it was a 15 kilowatt motor, which helps it out in low speed conditions. Electric only power. Plug-in hybrids also come into this category. Then the full hybrid, the only full hybrid car on sale now is the Toyota Camry. This is a series hybrid because it uses its, I think, 2500 cc Atkinson cycle. It's not an auto cycle. It's an Atkinson cycle petrol engine which powers its electric motors. It's got two electric motors, and that drives the car. So this is, you can say, a self-charging, hybrid vehicle. You don't have to plug it in anywhere. The engine provides all the necessary power it needs, the batteries, lithium-ion batteries, and that provides electricity to the motor, which propels the car. Now let's dive deep into this overview of the components. You have, as in the heart of the electric car, a traction battery pack, and you have this area here, which is the motor is on the axle. Obviously, you will have drive shafts on the left and right side. Then you would have a series of controllers and inverters, because the battery is not one entity. As you can see here itself, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 battery, 10 cells in one module, and you have 4 such modules. So 10 into 4 is 40. So 40, and that one module might contain around, say, 6 cells. So you can 10 into 40 into 6, around 240 cells. So 240 cells cannot be, managed by a single a mechanical device. So you would need a microcontroller to keep checking whether each voltage of each cell is correct, it's flowing correctly, the current is flowing correctly, it is not overcharging, it is not discharging at an irregular rate, it is evenly charging. So which is why there are complex things called BMS, battery management systems, in electric vehicles. Finally, you also have a controller controlling the motor, called a motor control unit, or simply a motor controller. And you also need thermal systems, which are cooling systems, which cool the batteries, because batteries do produce a lot of heat. And you need complex thermal management systems, and also another microcontroller to check the heat. Let's move on to battery types. Now, you might have heard of various battery chemistries. Lead acid is what we use in our day-to-day lives in cars, bikes. We have lead acid torch batteries, but that is the case. It is lead acid. You will also find VRLA batteries and gel-type batteries in motorcycles and scooters. You also have nickel cadmium, nickel metal hydride, manganese lithium ion, phosphate lithium ion, and also cobalt lithium ion. So when you check out the energy density of the last one, cobalt lithium ion, which is the yellow bar, it's 160 watt-hours per kg. So this is the best suited for any high power electronic electric vehicle application. Now, what are the advantages? Lithium ion has high energy per kg. It has a very long cycle life. What is cycle life? The amount of times you can charge and discharge. So you might have seen, OnePlus with their, I'm not sure what, it's 45 or 50 watt charging, fast charging, where you can charge 80% of your phone's battery in 30 minutes or something like that. So it might seem, easy for the power user like you and me. Fine, I put my phone for charge for 30 minutes and get, almost a fully charged phone. But how long will that battery last? The battery warranty is not for, hours used. It is for cycles. So unfortunately, within 1 year of me buying my laptop, since I keep charging it often, the battery went. And the battery warranty is only for, say, 6 months. So now I'm using my laptop with the power cord plugged in all the time. So cycle life, even though it is long, it is required. Slow charging is the best, but unfortunately, we can't, plan a huge trip, travel halfway, charge for 8 hours, sit in one place, charge your car for 8 hours, and then go on with the trip. That is not how we do it. Especially because we've got huge cars with huge fuel tanks nowadays, 70, 80 liters, and then 20, 25 kilometer mileage. So another advantage of lithium ion is its deep discharge, and it's highly efficient in storing and returning energy. Fast charge, I've told you the issues regarding fast charging. Now, low self-discharge. So assume this situation. You're going out on a business trip. You park your car at the airport. You go on, say, 2 3 days, and you come back. So when you park your car in the beginning, it might have had 100% charge. So after 2 3 days, when you come back, the charge would have depleted to say 80 percentage. So you must have seen, who would have taken my car? I mean, nobody would have taken your car. It's the car's battery. It's inherent quality to self discharge. So I think our phones also would have, you would have experienced the same thing with our phones. You leave it, unplugged and leave it alone for the whole day. You might lose around 3 4%. Same thing is with electric cars. And lithium ion, the most important thing is that it's maintenance free. Lithium ion as such is non-toxic, and disposal issues are not inherent. Now, as I said before, there are cells made up of modules and made up of battery packs. Therefore, we have to see the construction, what size, what shape the battery cells come into play are. So, cell shapes. You have cylindrical cells which you find in your torch batteries, but most familiar would be Tesla cells. Next, you have these prismatic cells, which every other manufacturer uses, and then you have pouch cells. Pouch cells are mostly used for appliances, smart electronic appliances, but the Chevrolet Beat electric car also used pouch cells. Now, the advantages or disadvantages. Mechanical stability is very high for the cylindrical cells, but how much cathodes and anodes you pack into it are very low, because you'll have to wrap it around, and there are inherent spaces inside the cell which can be effectively used but can't in this particular shape, which is why you come to the prismatic, where you have sheets of anodes and cathodes separated by your electrolyte, and you have much higher packaging density. Unfortunately, because of this high packaging density, you have very, very difficult thermal management. You can cool the entire module, but individual cell cooling is very difficult. In the cylindrical case, you have easier thermal management. Coming back to the pouch, it is the most easiest. You might have heard of, say, Jugaad. Indians, we are very famous for getting things done quick in an effective manner and a robust and cheap manner, which would be the best design. That's how we come to the pouch cells. But one thing you have to decide when you design the pouch, pouch cells swell up a lot. So while designing the space for your pouch cells, you have to take that space into account. Another thing, they shouldn't be placed near edges, as it poses a very high fire risk, which is why they are limited to consumer electronics. Let's move on to motor types. You have your brushless DC motor, switched reluctance motor, permanent magnet synchronous motor, DC motor, and induction motor. Let's keep it simple. There is a motor, it does something, it produces electricity. Through electricity, it rotates, it moves something. So how does this rotation happen? If I could take your attention to the first picture, you have a core, which is the rotor, and the outer core, which is the stator. So the rotor rotates and the stator stays in place. The stator has a lot of windings, and the rotor is basically a permanent magnet with north and south poles. So how do you rotate the rotor? When you pass electricity, I hope everybody can see my cursor. When you pass electricity through the coils, this line of coils, this becomes north and this becomes south pole. And when this is south and north, this would get attracted to this pole. This north would get attracted to the south, and this south would get attracted to this north. So while energizing this rotates. Once it comes to this particular pole, you stop energizing this coil and you energize these two coils. So this again attracts.
And similarly, once the rotor comes here, you stop energizing this coil and you start energizing this coil. So simultaneously, from energizing and disenergizing, this slowly starts to rotate. One extra thing you could do is while, let's take this, you're energizing these two with one particular polarity, you energize the one at the back with the opposite polarity. So if this is north and this is south and this is again north, this will be repelled by this and attracted by this. So once it comes to this particular place, you energize this and you de-energize this. So it keeps rotating faster. Now, we've established how the motor rotates and how the car moves. So let's see which motor is best suited for EV application. This is DC, this is induction motor, switched reluctance, PMSM, BLDC. BLDC and PMSM are the two most widely used motors for electric vehicle applications. What is the difference? They have equal power density, high efficiency. They can be controlled very well. The reliability is very good. They are cheap, relatively. They are relatively cheap to manufacture. Noise level is low, and they are maintenance free. So what is the difference? PMSM motors run on AC power. BLDC motors run on DC power. The PMSM has a sinusoidal waveform. The brushless has a trapezoidal and a square waveform. The brushless DC is slightly noisier than your PMSM motors, but these two are the best. So PMSM is used by the Ather 450X, which has been recently launched, the electric scooter. BLDC is every other manufacturer uses. Even our Nikki scooters are made using BLDC motors. Now moving on, these vehicles will be useless if they cannot be charged. So I will show you the charging equipment which is used by every manufacturer throughout the world. So you basically have two types. One is a fast charger, one is a slow charger. Based on the amount of electricity it has, it's split up into AC level 1, AC level 2, and fast charger, DC fast charger, and DC high power fast chargers. So I'll keep it simple. The one which you have in your house would be the AC level 1. The one which is, you charge your car to public charging would be DC high power chargers. Unfortunately, if you want a fast charger, you have to go to a public charging point, and because you cannot have the high power charger at your house, because this has to be directly connected to the grid. And our residential chargers come through a line of substations and sub-substations and transformers, which they aren't very reliable. So a direct connection to the grid, you get the most power fastest. Let's move on to the type of connectors used. Similarly, like a phone, you have a Type C, you have a Lightning connector. We have this charade in the electric vehicles as well. Saying Apple forcing you to put their own connector. You have Tesla forcing you to put their own connector. Nissan their own connector. Chevy their own connector. But a consortium of manufacturers have come up, and to reduce this whole circus, they've come up with standard connectors. For AC in North America, you have this J1772 Type 1 charger. In Japan, you have the same charger. For the European Union and mostly other markets, you have the Type 2 charger, and obviously China, being the red dragon that it is, has its own charger. DC chargers. In every single electric vehicle, I can't say fuel flap or fuel lid, charging lid, when you open, you would have, I hope everybody can see my mouse pointer, you would have this circle and also this curved rectangle onto it. So you can either charge using this connector or the whole DC connector. So coming to DC, there are very easy to identify ones called CCS1, CHAdeMO, CCS2, and GB by T. So AC is slow, DC is fast. And obviously Tesla has its own connector wherever they go. Now, this has, eventually led to me thinking, why do we have to, hybridize cars? You know, when we have 14 lakh two-wheelers being sold every month, why don't we apply this technology to a motorcycle? Obviously, it would be heavy, but then your Meteor and Thunderbird are already heavy. So, what's another couple of kilos going to do? So, thanks to Professor Sedipati and my colleagues Anirudh and a few others, we've come up with a small schematic of what we feel a hybrid motorcycle would look like, and I'm sorry, my power went out at my house. Can you still see my screen? I'm sorry, the power went out at my house. Can you still see my screen?
Yes, sir. Yes, sir. Yes, sir. We can see.
Hello?
Yes, sir. We can see.
Hello.
Yeah, it's visible, sir. Yeah, sir.
I'm sorry for the interruption. I'll rejoin. Give me give me a moment, please. Hello.
You are audible, Nishant.
All right, thank you, sir. My apologies, everybody. The current went off. The power went off in my place. It took some time to connect to the Wi-Fi again. I'll share my screen again. I think we were here, correct?
Yes, sir.
Okay, right. So, as I was saying, we've come up with a small schematic of what our eventual, uh, concept might look like. So this is what our, creation is, as Frankenstein would call it. You have an engine here, a single cylinder diesel engine powered by biodiesel, B85 to be B50 to be precise. Without a gearbox, you would find a lot of Greaves, Cotton engines and Simpson engines running on biodiesel without any modification whatsoever. So you have your engine and its primary drives connected to your alternator, which converts mechanical energy to electrical energy, and that is connected through a series of power inverters to uh, step up, step down, get the voltage to what it actually should be, and it gets connected to your battery pack. Finally, your battery pack is connected to your hub motor, which is in the wheel, through electrical connections, and that is what powers the whole motorcycle. So as you can see, this is the front of the motorcycle, and it would be heavy, but you still have heavy steel constructed bullets, classic 350s out there, right? So I'll go on to the specifics. So this is what we simulated. We kept the smallest possible biodiesel run engine, which had an engine horsepower of around 8. The battery capacity, smallest one, which could be off-the-shelf built, was around 4 kilowatts. And the only thing we could play around with after gradient calculations and aerodynamic drag calculations was the motor power. So the motor power which we theoretically got was around 6.7. Obviously, we converted to HP was 6.7 HP, but commercially available was 5.3 and 8. So assuming you get things ideally, your charge time for that particular battery pack by the engine would be 40.8 minutes, and the fuel required for one charge, that is for one charge of the battery pack, would be 0.42 of biodiesel. So how much could that run? It could run 31 kilometers, and the number of times battery can be charged with that um, fuel which is there in the tank. Standard tank for an Avenger was 12 liters, so 12 liters would be roughly 31 times the battery can be charged. So a total theoretical simulated range was around 980 kilometers. So obviously it would differ based on real world conditions, temperature, weight, road, the tires, the stiffness of the tires, rolling resistance, all that. But this is what we came up with. So I'll tell you how this actually works. So you put fuel in your diesel tank. The engine charges the battery powers the motor, and the motor moves the motorcycle. Now, once the battery is depleted, the engine recharges the battery again powers the motor, and the motor moves the motorcycle. Finally, once all the diesel is depleted, you fill the tank back to the brim, and the whole cycle starts again and again and again till wherever you want to go. So this was our small creation, and the way forward for this, the same technology we can horizontally deploy to something which is commercially viable, like a three-wheeler. Big Basket, Amazon delivers their products in Tata Aces. They can use, say, our technology in a Tata Ace or even Piaggio 8 for that matter. So you would have zero downtime because of charging. You would not have downtime because of vehicle breakdowns. You would not be polluting the environment. And obviously, this engine, you might say it's still an internal combustion engine, but it's a BS6 or a Euro 6 biodiesel engine. And there are plans to bring in biodiesel. There are even plans to bring in higher amounts of ethanol in your petrol. So in that case, we will not be facing issues. So this is about it of our research paper, and this concludes my lecture. Thank you very much for your time. I think we can move on to the question and answer session now. I will also put in a link for our research paper. Whenever you're free, you can please view. Thank you very much.
Thank you, sir. That was an amazingly enlightening talk. I'm all of us have learned immensely from it and entered a wider horizon of thought process as student and as engineers. Now, to all the participants, positively fill up the feedback forms. The link is in the chat box, and the link will be active till 1 hour after the end of the tech talk. The e-certificates will be provided based on attendance and submission of feedback form. Now, I request Mr. Nishant Govindarajan, sir, to please resolve doubts from the participants.
Sure, definitely. I can see one by Mr. Sanjay. Tamil Nadu garbage vehicle. Yes, exactly. That also can be done. Electric vehicles can be used especially for these sort of services, and I think very few are being used by corporations. I think one Mare Nagar Corporation had one such vehicle. I wasn't sure whether it was electric, but that could be converted to electric. Ampere Electric Vehicles also has custom application built vehicles for that purpose. So thank you for that. Yes. Any questions I would like to discuss?
So you missed a couple while you rejoined. Sir, I'll read it out.
Yes, please.
Tanay Sureka asks, so since cars are connected to one another, is it possible that the cars may be overridden by hackers?
Yes, I think, yeah, I think I can see where the question is coming from. You might have seen the Fast and Furious movies where Cypher, hacked all those cars. That is very much a possibility, and which is why we need complex blockchain technology to prevent such cyber threats from, popping up in the first place. Failure modes in effect analysis can be even applied to all this, to prevent hacks, to prevent vulnerabilities in your system. And the main place where we have to implement blockchain is one in the car, but also at your data centers, which relay information to one, the manufacturer, and also the service provider. That is very important. Plus, you shouldn't have this sort of a connection where you hack one car and you gain access to every single vehicle in the portfolio. That has to be very carefully taken care of.
There is another question by Devansh Ved. Is the import duty on cars in India justified, considering how behind we are in innovation despite producing a large number of engineers?
Yeah, absolutely. A very, very great question. Thank you. You might have seen a lot of memes on Instagram from not sure what it's called, don't remember the name, but you might have seen, BMW 7 Series costs 75 lakhs equivalent in the Americas, EU, and finally when it comes to India, it'll be around 1.5 crores. Because that is imported to India as a CBU, which is a completely built up unit. There is no assembly, no manufacturing done at the home country, which is India, and it's directly imported from either Germany or Austria. So which is why any car not being homologated for the Indian conditions faces an import duty of 100 or in some cases 150% also. So imagine you buy a car for 75 lakhs, you have to pay another 75 lakhs to the government just because you don't want to use something which has been tested in India. But there is one small exception to this rule. Just last year, the government allowed 2,500 cars of any manufacturer, which can be sold without a substantial increase in import duties, and they need not be homologated for Indian conditions. You need not take it to say RI or GARC or ICAT to get it sorted for the Indian conditions. As long as it is BS6, as long as it has safety features, crash test, compliant cars, and the mandatory horrible speed reminder we have at 80 and 100 kmph, you can sell up to 2,500 units a year. Which is why you have, last year we had the Volkswagen T-Roc, Toyota introduced their Wellfire, and recently their Hiace also, without homologation in India.
Okay, sir. There are a couple of questions from my side.
Yes.
So, what are the opportunities for mechanical engineering students in upcoming Industry 4.0?
Well, you might have seen those roles where you have automation. You have, I think Bosch Rexroth Center itself at SRM, I think Professor Sethupathi is there. He's the coordinator for that. The pneumatics and hydraulics technology, including the PLC, that itself helps you to gain an access into the world of automation. Plus, it doesn't matter whether you're a mechanical engineer or an automobile engineer or a mechatronics or electrical or electronics or CSC. Everybody should be, at least known in some point of time about the issues the other person faces, and they must be able to work as a cross-functional team. You can't say, I'm a mechanical engineer, I don't know anything about electronics. If you have an issue with my design, it's your problem. That you shouldn't say. That's not how the company works. Suppose you have a system which entirely focuses on ABS. Say person one who's a mechanical engineer makes the brakes, the actual design of the brakes and the braking system and all that. Second person would be a CSE person, a computer science person who does the coding for the ABS controller. Third person would be the electronics person who says, okay, I've got to integrate all this together. Suppose he asks you, okay, this is my design. This goes into the top of the brakes here, where you have the bleeding nipple, and there's a smaller controller there, or a controller input which has to be used. So can you change your design in such a way that my control unit is on the side, so it prevents, even if your brake fluid leaks onto the controller, it wouldn't be an issue because it'll be shielded. So suppose you say that's not my fault who asked you to make a controller, then that, that defeats the purpose of working as a cross-functional team. So this sort of design thinking is very important. Even if you are a mechanical engineer, you must see, okay, this person has the control unit here. I must design in such a way that even if there is spillage of brake fluid, it doesn't hamper the system and affect the end user, which is the consumer. The brake should not fail because of something which is very nuanced, like a fluid on a controller. So that sort of design thinking and empathy is really required. So irrespective of whatever job you be, and so ultimately what I'm saying is, a mechanical engineer should know what an electrical engineer does. Electrical engineer should know what a mechanical engineer does. We can't just limit ourselves to being a mechanical or electrical or CSE engineer. So this certain things like Lean Six Sigma, DFMEA, PMP, project management professional, all this thing is irrespective of the department you are in. This helps you do your job better. So this is what I'm coming to, ultimately say.
Okay. So a couple of questions more. So in the near future, will there be more will the cars be more cost efficient so that ordinary people can also afford it? And if so, how long might it take?
Right. So now there are the cheapest, I won't say cheapest, the most affordable car in India is the Alto 800 or the Renault Kwid. We have two options. So these two would start from anywhere around 3 lakhs and would go on to 5 lakhs. So the amount of regulations which have been made for every car from 2020 is that every single car sold should be BS6, which means it should pollute the environment lesser than its predecessor. It should have a crash-worthy structure. It should have a mandatory driver side airbag, and from 2021 August, it should have a passenger airbag also. ABS should be mandatory, rear parking sensor should be mandatory, and seat belt reminder should be mandatory. And obviously the horrible speed warning system, which beeps at 80 and 120 kmph. Right. So why have all these regulations been put into place? Obviously, when you see the BS4 car and this car with all these things I said, it would have easily increased the price by around 50 to 60,000 rupees. But why is this being done? It is being done to safeguard the citizen, safeguard the consumer who is using the car. So those two are the only cars which are relatively, affordable. But if you go on to say a used car, but not the used entry-level car, say a used Corolla Altis, which in its day was sold at around 15, 18 lakhs. That even a 2003 Corolla Altis had ABS, had airbags, had a crash-worthy structure. So those cars would be a more viable option till you get the hang of the car, get a hang of the insurance, the POC, all the things, the additional costs compared to the car. Then you might as well go on to a new car. That need not be an entry-level car. 5, 6 years down the line using a used car, you can go on to say, a mid-level or a premium-level hatchback, which would have even more better safety features than an affordable car.
Okay. So one more question. So, role of automobile journalism in India.
Role of automobile journalism in India. Okay. Do you want? Could you elaborate further on that? Can you unmute the person?
Mr. Sanjay.
This is Sanjay. I have lots of background noises, so I have enabled the TV to off.
Yeah, no problem. You can continue the question.
Yeah, sir. It's my passion to be in an automotive journalism field. So,
Great.
as to
Okay.
know about the lots of things about automotive journalism, I'm searching for the results. What is the important role of the automobile journalism team in India? What is the key role they play out there in the sales and extra features and factors?
Right. Okay. I might not be able to answer your question completely, but since I follow people like journalists like from Autocar India, Top Gear India, Motor Octane, Part and all that, I might be in some position to answer. Uh, well, what does being an automobile journalist mean? It means that you get the news first. You get your comments are better understood by the manufacturers and taken into account, because what the media, you have media drives which are conducted by the OEMs, just so that the journalist sees how the prototype car prototype car drives, how the features are, and then the same thing, their opinion would be, disseminated into the audience through various channels like YouTube, through digital media, through print media. So their opinions are taken very, very highly, because they can decide, their followers can decide whether your car is a success or a complete failure. You must have seen the impact that the uh, one or two posts of the Nissan Magnite's build quality came into the picture. They said, they pressed the dashboard and said, "This, there are too many panel gaps here. The quality is very low. All this," and this forms an opinion for the people, the end consumer who are watching those videos. So after those videos came out, if you see the booking order, they slightly dropped. For 1 month, those booking orders dropped. So they were going off at around 3,000-4,000. It dropped in it to around 2,000. Then it went back again. So you cannot say that is the only factor, but it is one of the deciding factors. You also have paid promotions where the OEM will pay you to say good things about their car, to focus only on the positives and not the negatives. So automotive journalism is a really nice field. You get to people. One up and coming YouTube channel I found was Motor Wagon. So Motor Wagon has a higher reach, especially in South India, because they use their language of use is Tamil, which I felt was very nice.
Yeah, sir. Yeah,
Yeah.
yeah, thank you.
Nissan, can I add one more information over here?
Yes, sir. Please.
Yeah, for motor vehicle, one of our alumni, one of our mechanical alumni, his name is Mr. Siddhi Chakravarti, who is taking care of yes, the motor vehicle, Tamil this thing and English also.
Right,
If
right.
person wants to continue this thing, and better I can use his contact after this meeting. Okay,
Great.
he
That's
is
great,
interested
sir.
in we can jointly we
Yes,
can work with them.
that's great, sir.
Apart from
Thank you
that,
very much. Thank you very much.
something called yeah, to make one India. They are
Ah,
doing
yes,
a
yes, Automat.
totally
Yes, yes.
Thank
That's
you.
great, sir.
Yeah,
Thank
thank you
you.
very much, sir.
So, Mr. Sanjay, thanks to Mr. Sethupathi, you already have a connection here. And thank you, sir, for joining the call, because you have great connections everywhere, and your network is very impressive and very commendable. So, I
Yeah,
think, Mr. Sanjay, you can drop in.
to Seribadi sir and Nishant sir as well. It's huge having a time spending with you.
Yeah, thank you very much. So, I think if you can drop in your contact details, I'll share them with sir, and sir can connect you to the correct people to improve your career in automotive journalism. All the very best.
Thank you
I
for
think.
this, sir.
Thank you. Next question, please.
So electricity is generated in coal, which in turn causes pollution. So what difference does it make to use an electric vehicle instead of fuel-powered one? Could you
Right.
highlight the advantage?
Yes, charging of electric vehicle is highly important. You can't use coal-powered sources to charge your car. You have to use either solar or wind energy. Wind energy is really picking up in India, and I cannot say a substantial value. Around 3 to 4% of India's electricity consumption is electricity made by wind energy, and solar energy also plays a huge role. And this is how you have to use your electricity to charge your cars. You can't use fossil fuels again. If you use fossil fuels, it is equivalent to you driving a diesel car. So it has to be through renewable sources of energy that you charge your cars. But there is another issue. If say 10,000 cars are plugged into the grid every night, it would be a huge load onto the grid. So this itself is a huge issue which has to be addressed. So everybody can't charge their car at the same time. But that is not the case for filling petrol. You can have 10, 20 people filling petrol at the same time because that is individual, entities. But this issue really persists for electric vehicles.
Okay. Can India become the next China for car makers?
Well, China's first, second, I think, is US, followed by Europe, and then us. We were in the fourth place. We are in the fourth place. Slowly, we are poised to become the third or fourth. It's a little difficult to overtake China because their policies are more forward. They even have policies which promote hydrogen-powered fuel cell vehicles, whereas we are fighting to get, tax rebates for electric vehicles, let alone hybrids. So their policies are more forward in that direction, and I feel overtaking them would be a mammoth task. And especially now because we have a string of rule changes in place. This year alone we had the BS6. Next year we will have CAFE norms, which means every car has to produce more fuel efficiency than now and before. Then the next year we're going to have real driving emissions, which means just testing your car passing emission in a lab is not important. On the road, your car has to pass emission tests. But this will really weed out people like Volkswagen, who at one point of time cheated in their emission, and Daimler also. So these string of rule changes will hamper growth in the country, but we would have proper cars, which pollute the environment lesser. After that, who knows? Maybe BS7, BS8 might come into the picture and reduce growth again, or we might have an EV only future. But I feel in India it's very difficult to have EV only. So even in 2030, you might have 1% or 2% penetration of EVs among the whole cars. So we can become one of the largest auto markets, but not in the near future.
Okay. So I think we have time for one last question.
Sure.
This is by Sovik Roy. I think this is a question in sustainable development. So lithium ion mining requires 2 million liters of water for just 1 ton of lithium ion, and the batteries will need to be replaced after max 5 years. So do you think that electric cars are the future of the automobile industry, considering the fact that IC engines have come a long way with the recent introduction of BS6 engines? So
yes, I understand. Thank you for that question. It's a really good question. It sees the overall, the bigger picture. So electric vehicles are the future, but not electric vehicles powered by batteries. Electric vehicles powered by fuel cells, hydrogen fuel cells, are the future. Because hydrogen fuel cells just emit one thing, which is water. But finding a place to pump in hydrogen safely is the issue now. The whole of the United Kingdom has only 6 hydrogen fueling stations, whereas China has a lot more. But then hydrogen fuel cell electric vehicles are the future, in my honest opinion. You also might have range extenders. Those range extenders would be petrol or diesel single cylinder or 2-cylinder, at the maximum 3-cylinder engines. So you cannot just say, fine, I am not going to develop my IC engines anymore. I am done with BS6. I am done with CAFE. I am done with real driving emissions. No, you have to keep improving. You have to keep improving your IC engines, because it might just end up as a range extender in your hydrogen fuel cell electric vehicle. So in that case, at least you will definitely, develop your IC engines further. And as I said, hydrogen fuel cell electric vehicles are the future, not battery powered ones.
Okay. I think
Good
that
question.
answers Sharad Mohan's questions also. I think, thank you, sir, for clearing all the doubts with such patience.
Any more questions, you can reach out to me on LinkedIn or my email ID as well.
Yes, sir. This was an amazingly rich experience for all of us present here. Also, a heartfelt thank you to Mr. A. Vinod sir for making this happen. And in the end, thank you for all the participants. E-certificates will be mailed to you directly, or a G Drive link will be made available where you can go and download your certificate freely. Also, if you want to be a part of SRM Material Advantage Student Chapter, please contact us on Instagram, LinkedIn, Gmail, or Facebook directly. Details will be available on the screen and will be mailed to you along with the certificates. More such talks and many great events are coming. Be sure to join if you're interested. On this note, we conclude today's talk. Thank you everyone. Thank you, sir.
A small word of thanks from my side. Thank you very much, everybody, for attending. It really was great to, it was amazing to, get your invitation in the first place, and it was amazing to interact. Thank you, students, for attending. Thank you. I would like to thank my professors, Professor Sedibadi, few of my LinkedIn connections, also Dr. Prabhakar, Dr. Vijay Raghavan. Thank you, sirs, for attending, and hope everybody had a good time. Thank you. Take care.
Yeah, congratulations, Mr. Nishant Gandrajan.
Yes, sir.
Really, you made this evening is very useful. I hope nearly 40 plus, I think around 50 participants get the benefit, including numbers and student members. The way you presented the presentation, the energy level, especially energy level, since beginning to the end, the rest is phenomenal. Yeah, really, I'm very happy to see you on this level. All the very best for your future.
Thank you very much. Thank you very much for your kind words. Thank you.
Also, I would like to thank this association. I think this association also is doing a good job. Okay, the material association. My congratulations to this association also. Thanks.
Thank you. Thank you, sir.
So hi Nishant, Vijay Raghavan here.
Hello, sir. How are you? All well.
Yeah, very good, excellent presentation, and you have answered many of the queries raised by the participants. So thank you
Thank you.
for your session here.
Thank you for attending, sir. It was nice to have you here. Thank you.
I have also asking you to give a presentation, but you are escaping from me and giving presentation to others.
Anytime, sir. You can get it done.
So, sir, this presentation is enough for all of us. Hereafter, I think Nishant will be more busy. Already, he is going to be lecture, I think, next week. So, Hari Brother